Hello, everyone. In today's lesson, we will continue learning about PLC control in vending machines. 5. Other mathematical operation instructions. Below is a table of some common mathematical function instructions. We will explain some commonly used mathematical function instructions, while others you can study on your own. 1. Application of mod neg and ABS instructions. The mod instruction is used to calculate the remainder of integer division. In the mod instruction module, the data types of parameters in1, in2, and out must be integers and must match. While the division instruction only gets the quotient, the mod instruction returns the remainder to out. For example, in figure 14.8, in1 divided by in2, 123 divided by 21, gives a quotient of 5 and a remainder out of 18. The neg instruction is a not instruction. The neg instruction can be used to change the sign of the value in the input in and check the result in the output out. For example, if the input in is a positive value, the negative value is sent to out. In figure 14.8, the neg instruction module shows that the negation of integer 25 is minus 25, and the negation of the floating point number 3.14 is minus 3.14. The ABS instruction computes the absolute value of the specified input in, and the result is sent to out. In figure 14.8, the ABS instruction module shows that the absolute value of minus 6.28 is 6.28. 2. Application of SQR and SQRT instructions. The SQR instruction calculates the square of the floating point value in input in and writes the result to out. The SQRT instruction calculates the square root of the floating point value in input in and writes the result to out. If the input value is greater than 0, the result is positive. If the input value is less than 0, the output out returns an invalid floating point number. If the input value in is 0, the result is also 0. In the diagram, the value y equals the square root of the sum of 2 squared and 5 squared is calculated. The program uses the SQR instruction to calculate the squares of 2 squared and 5 squared, the ADD instruction to compute 2 squared plus 5 squared, and the SQRT instruction to compute the final result, which is then transferred to MD100. All data types used in the calculation are floating point numbers. Next, we will explore the content of this task through a specific example. Case 1. Soft drink and coffee vending machine program development. Task description. The vending machine accepts 1 yuan, press S0, 5 yuan, press S1, and 10 yuan coins, press S2. When the total value of the inserted coins equals or exceeds 12 yuan, the soda button indicator light L1 turns on, indicating that soda can be purchased. When the total value of the inserted coins equals or exceeds 15 yuan, both the soda and coffee indicator lights turn on, indicating that both soda and coffee can be purchased. When the soda button indicator light is on, pressing the soda button dispenses soda, which stops automatically after 7 seconds. While dispensing, the soda outlet indicator light Y1 flashes. When the coffee button indicator light L0 is on, the operation is the same. If the total value of the inserted coins exceeds the required amount, soda 12 yuan, coffee 15 yuan, the change indicator light L3 turns on after the purchase. The change process ends after 7 seconds, and the L3 light turns off. Task implementation. 1. I or O address assignment. Input signals include buttons for inserting 1 yuan, 5 yuan, and 10 yuan coins. 2 buttons are needed for purchasing soda and coffee. Therefore, as shown in the table, there are 5 input signals. For output signals, after inserting coins, if the amount exceeds 12 yuan, the soda indicator light turns on. If the amount exceeds 15 yuan, both the soda and coffee indicator lights turn on. Thus, 2 outputs are needed for the soda and coffee indicator lights. When purchasing soda or coffee, there are indicator lights at the soda and coffee outlets, so 2 more outputs are required. Finally, a change indicator light is needed when the total value of the coins exceeds the amount required. In total, 5 output signals are needed, as shown in the table. 2. I or O wiring diagram. As shown in the diagram, connect 5 input buttons and 5 indicator lights according to the I or O address allocation table. 3. Program debugging. 1. Counting the number of each coin inserted. Use counters C0, C1, and C2 to record the number of 1 yuan, 5 yuan, and 10 yuan coins inserted. Assign the current values of counters C0, C1, and C2 to MW0, MW2, and MW4, respectively. 2. Calculating the total value of inserted coins. A. Multiply the current value of each counter by the coin value using multiplication instructions. For example, MW0 times 1 yuan gives the total value of inserted 1 yuan coins, assigned to MW10. Similarly, MW2 times 5 yuan gives the total value of inserted 5 yuan coins, assigned to MW12, and MW4 times 10 yuan gives the total value of inserted 10 yuan coins, assigned to MW14. B. Use the addition instruction to sum the values of the inserted coins to get the total value of the inserted coins. MW10 plus MW12 plus MW14 gives the total inserted coin value. 3. Determining if the inserted coin value is enough to purchase items. Use comparison instructions to compare the total value of inserted coins with the amount required to purchase items. If the total value is less than 12 yuan, neither the soda nor the coffee indicator lights turn on, indicating that neither item can be purchased. If the total value equals or exceeds 12 yuan, the soda button indicator light L1 turns on. If the total value equals or exceeds 15 yuan, both the soda and coffee indicator lights turn on. 4. Controlling the dispensing time for soda and coffee. When the soda or coffee button indicator light is on, pressing the soda or coffee button starts timer T1, which runs for 7 seconds. When the timer expires, the corresponding button indicator light turns off. 5. Controlling the flashing of soda and coffee outlet indicator lights Y1 and Y2. Use the timer T2 instruction to time 1 second. When the time is up, output the signal M3.0. Then use the normally closed contact of M3.0 to interrupt the timer, resetting the timer. As the normally closed contact of M3.0 closes again, the timer starts timing again. This process repeats until timer T1 reaches 7 seconds, at which point timer T2 is reset. The timer T2 has a cycle of 1 second. Using the compare instruction, the timing can be controlled as follows. When T2's timing is between 0 and 0.5 seconds, the soda and coffee outlet indicator lights Y1 and Y2 remain off. When T2's timing is between 0.5 and 1 second, the soda and coffee outlet indicator lights Y1 and Y2 turn on. Thus, as the timer T2 continues to repeat its timing cycle, the soda and coffee outlet indicator lights Y1 and Y2 will continuously turn off and on, achieving a blinking control effect. 6. Controlling change dispensing. After soda or coffee dispensing ends, use the subtraction instruction to calculate the difference between the total inserted coin value and the required amount. If the difference is greater than 0, the change indicator light L3 turns on and timer T3 starts timing for 7 seconds. When the timer expires, the change indicator light L3 turns off. The program diagram is shown in Figure 1411. (4) Program debugging. Download the program to the PLC and then debug. 1. Press the coin insertion buttons and check if the counts for 1 yuan, 2 yuan, and 5 yuan are correct. 2. When the total value of inserted coins exceeds 12 yuan, check if the soda indicator light turns on. When the total value exceeds 15 yuan, check if both the soda and coffee indicator lights turn on. 3. Press the soda and coffee dispense buttons and check if the corresponding outlet indicator lights turn on and flash, and if they turn off after 7 seconds. 4. When the total inserted coin value is not 12 or 15 yuan, check if the change indicator light turns on and turns off after 7 seconds. If the program does not meet the design requirements, modify the program until it passes all checks. Practical example: self-service car wash system PLC program design. Each car wash token dispenses water for 15 minutes. During the car wash, you can stop the water at any time to wipe the car. Pressing the start button again resumes water dispensing. However, a car wash token allows for water dispensing within a maximum of 20 minutes from the initial button press. The total dispensing time is 15 minutes, or if the 20-minute limit is reached from the initial button press, the car wash is considered complete, and a new token is required for further dispensing. Please practice this independently after class to reinforce what you have learned. This concludes today's lesson. Thank you for watching.